All right, hey, 3B class. This is the video I promised you yesterday. I didn't really get around to it, but hopefully I can keep this really brief. I just wanted to wrap up our in-depth look at 250. Hopefully the videos were helpful. It does appear as though very few of you have watched them, but as long as you're understanding the code and how to navigate it, then you're doing a-okay. As far as this first week is gone, I think we got through pretty good. We picked up a few students that had mistakenly said they wanted to wait till Tuesday, and they're going to be hard pressed to catch up for the week. But that's okay as long as they're willing to commit to the work. But I just wanted to do this one little wrap up video. And heck, man, I just recorded one and forgot to turn the mic on. And so now here I am doing it again. But that one was 12 minutes long, and I'd like it to be a lot shorter. So anyway, just to wrap up what we were looking at, and just to pick up some loose ends on some things I forgot to explain, I just wanted to do a brief overview of a grounding system again and its key components, and then tie the tables or the sizing tables to those for your convenience. Like I said in the video, we would drill these in class. So I would be like, how do you size a grounding electrode conductor? And the class would shout out 250.122 and then say, no, you dumbasses, that's wrong. No, I wouldn't do that. I'm just kidding. They'd get it right. Anyway, and I apologize for the swearing. In any event, the grounding system of a building is comprised of three main components. Two are rather large, and the best way that you can think of that is that there's a part of the grounding system that is before the service and a part that's after. So the part that's before the service would be our grounding electrode system that establishes an earth connection for our electrical system and allows for things like surge current and lightning to dissipate into the earth. The other side is the side that's past our service or our main breaker, and that's our equipment grounding system. And then we know what that's for. That's for personnel safety and just to make sure that if there's any ground faults, the breakers operate open and remove that safety hazard. And then in the middle, a very small part is our bonding jumper. Okay, and so the tables that are associated with that are for grounding electrode conductors. We look at table 250.66, and we look at the chart, and it asks us to size the bonding jumper and the grounding electrode conductor based on the size of the service entrance conductors, and it's just one phase, right? So one thing that I failed to mention in the video that I wanted to wrap up is that the chart isn't always used. It's used up to a certain point. So for some grounding electrodes like UFERs and ground rods, it would be impractical to try to connect a 2-aught copper or 3-aught aluminum to the ground rod. And so the code actually gives us a maximum size that is required. And a lot of you probably know this, but for UFERs, it's 4-aught copper, and for ground rods, it's 6-aught copper. Or no, what did I say? 4 gauge. So not 4-aught, but 4 gauge copper for UFERs and 4 gauge or 6 gauge copper for ground rods, and you're not required to put anything in larger than that for those electrodes. And so you have to be careful because there'll be a grounding electrode part of section or article 250 in part 30 that just talks about the electrodes, and it'll list them: concrete encased, ground rod. And then there's another section that happens just shortly after that that's for the conductor sizing. And it'll be in the same order, and a lot of those sections will be labeled exactly the same, and you just have to make sure you're looking at the right one If the question asks about the electrode, then you're looking in the electrode section. And if it asks about the conductor for the electrode, then you're looking in the conductor electrode. The equipment grounding side, because it's past the main breaker, for the most part, is just sized based on the breaker size. So we know that, right? We have cables. They have the proper size ground in them based on table 250.122. Okay, so we have two tables so far, 250.66 for grounding electrode conductors, 250.122 for equipment grounding conductors. 250.66 is based on the size of the service entrance conductors of one phase. And then again, if they're paralleled, you have to add the total surface area. And then the equipment grounding conductor is sized based on the breaker size of the circuit that it is associated with. Okay. And then in the middle, the main bonding jumper, which allows for the two systems to be connected so that if lightning were to strike the electrical system, it would have a place to dissipate into the earth, right? And also any surge voltage. And then it also kind of, the main bonding jumper does provide some sort of fault current path for equipment grounding. Though the main aim of our equipment grounding system plus our electrode system is to just make sure that there's an unimpeded path back to whatever source the energy comes from. So whether it comes from the transformer or the generator or from the sky as in lightning. And so the main bonding jumper, like I said in the previous video, it used to be sized on 250.66, and there used to be this nice note 1 or whatever it is underneath that said that if they were larger than 1100 kc mils, then you had to make sure that they were 12.5% the size of. So if you had 200 K or 2000 kc mil service entrance conductors or 4 parallel 500 kc mils for one phase, then you would have to times 2000 by 12.5, which is 25, right? 25%, or not 25%, but it would be yeah, because I did 1,000, so it would be 250 kc mils, or maybe 25,000 kc mils. We'd have to double check the math, but either way, that's kind of how it works. If it were 1,000, that would be 12.5% of 1,000. But we have a new table for bonding jumpers over the last couple of cycles, and it looks very much like 250.66, and it's found in part 5, which is the bonding section. But it does have the note, and that's table 250.102 C1. So just make sure you get those straight. If the question's asking about a bonding jumper, then you go to 250.102 C1. If it's asking about a grounding electrode conductor, 250.66 and equipment grounding conductors, you should definitely know by now. 250.122, and all of those tables, I believe, are found in the Uglies book. Maybe not the 250.102 C1 since it's new, but the other two are. And so when you're taking quizzes and you're taking exams, just have the page open with those tables, and then then you can just thumb through your code book to find the other answers. And then when you come across a sizing one, then the charts are open there already for you. But anyway, again, guys, great week. We're rocking and rolling now, and I will look into chapter 3 to see if there's anything that needs any special explanation and make videos. But basically, it's just going to be about some specific bonding and grounding requirements that happen in that chapter, such as limiting the length of flexible metallic conduit, the use of armored cable sheathing for grounds, bonding metal boxes, grounding metal boxes, that kind of stuff. So anyway, again, great week, and we'll talk to you later.